Concept number 6. The best thing about it is the enrolled students will also get my copyrighted classroom notes, which is not available in the market. Only the students who enrolled will get about close to 3000 plus problems solved it in my notes. Also you will get it. That we gave it for an enrolled students absolutely freely. You enroll for placements, I have given you little beyond what comes in placement so that you are acquainted with little complex problems. I believe in saying less and doing more job. I told you that there is one class 5 to 7. So I am taking from the last 3 days, morning, afternoon, last 2 days, 3 classes. Say less, work more. So that's exactly the reason I always like people who speak less and execute things with their work. Right work should speak. Concept number 6. How to find the value of a square root of a perfect square. How to find the value of a square root of a perfect square. Listen carefully, sir. How to find the value of a perfect square. At the end, I will discuss Madhulata. Let us concentrate on the subject. And last, I will discuss how to find the value of a square root of a perfect square. Suppose, for example, square root of 1521 is there. Square root of 7754 is there. Square root of 5929 is there. 5929. Square root of 12544 is there. 4-digit number and a 5-digit number. Now, see here, sir. First thing, listen carefully, sir. Square root of 1521. Square root of 1521. Step number 1. Start from the rightmost. Keep a slash after 2 digits. After 2 digits. How many groups of 2 digits are there? These one group, 21. These are another group, 15. This will tell answer has how many digits. Take a slash after a group of 2 digits. How many groups of 2 digits are there? That answer will be that many digits in the answer. Keep a slash. 44, it is one group with 2 digits. 77 is another group with 2 digits. So, 59, 29. 29 is one group. 59 is one group. 12544. Here it is slash slash. 1 can be written as 0, 1. So, answer is nothing but a group of 3 digits. Answer is nothing but a group of 3 digits. I hope the idea it is clear. Before we solve the problem, let us see some more questions. 996004. 996004. How many digits are there in the answer? He is not asking you the value. He is asking how many digits are there in the answer. Take a group of 2 digits. Take a group of 2 digits. Answer contains how many digits? 3 digits. Answer contains how many digits? 3 digits. Suppose, for example, 982, 081. 982, 081. Take a group of 2 digits. Answer contains how many digits? 3 digits. Keep a slash after every 2 digits. Keep a slash after every 2 digits. Move from the right to left. Keep a slash after 2 digits. This is working for the square root of a. This is working for the square root of a perfect square. Can I extend the logic for a cube root of a perfect cube? Definitely yes. That also we will discuss. Square root of a perfect square, if you need to determine, start from the rightmost. Keep a slash after every 2 digits. Suppose if it is cube root of 32768. 32768. Cube root of 68921. Cube root of 112. 4864. Answer contains how many digits? Cube root value. Answer contains how many digits? Number of digits. How many will be there in the answer? cube root of 32768, 68921 and cube root of 1124864. Because it is cube root, keep a slash after 3 digits. 32 can be written as 032. Answer contains 2 digits. Answer contains 2 digits. 68921. 68 can be written as 068. Answer contains 2 digits. If it is 3 digits, 1 can be written as 001. Answer contains 3 digits. Answer contains 3 digits. I hope it is clear, right? If it is nth root, if I want the nth root of perfect nth power, if I want the nth root for perfect nth power, take a group of n digits. Take a group of n digits from RHS. Take a group of n digits from right hand side. If I take a group of n digits from right hand side, that will give you number of digits. I hope this idea it is clear. Kindly reply in the live chat if this idea is clear. Once a class starts, it will be continuous problem solving. Even if class starts at 3, I started my first problem at 3:05. I will keep on continuing till 5:05. In case if I do not complete the topic, I will first take the topic that is pending and I will first finish it off. If I do any job, I believe in doing the job sincerely. Otherwise, we should not do that job. Because a work is a prayer which I offer to God. When I am taking class to you, I consider it as complete surrender of silence when I am there in front of God. Right? That is the kind of dedication, because all the students, I do not know which place you are from. You are sitting somewhere and watching my class on the mobile. It's a responsibility of me to ensure that your time becomes the most productive time with Anil Nair. I hope it is clear. Square root, number of digits, cube root. Now we will find out the values. Square root of 5329. Square root of 5329. Keep a slash after 2 digits. 9 means 9 will end with either 3 square or 7 square. Are you with me? I told you yesterday, 10's complement, 3 square or 7 square. So answer will have unit digit either 3 or 7. 53 lies between which two perfect square? 7 square 49, 8 square 64. Take the smallest value. So answer is either 73 or 77. Yesterday we discussed a logic. 75 into 75. 5 5s are 25. Add 1. 8 7s are 56. 5300 is less than 5600. Answer has to be 73. Answer has to be 73. If you are good in finding this answer, do this. Otherwise, use the concept of a digital sum. 5329 is nothing but 73. Assume it is 73. Square it on both the sides. 5329 equivalent to 73 whole square. 9 can be cancelled. 5 plus 3, 8. 8 plus 2, 10. 10 digital sum is 1. 7 plus 3, 10. 10 digital sum is 1. 1 square it is 1. Digital sum is matching. So therefore 73 is the right answer. Check whether LHS is equivalent to RHS in terms of digital sum. In terms of digital sum, check whether LHS is equivalent to RHS. I hope the idea it is clear. In case if you are not comfortable with the 75 into 75, you can do it. Let us check whether 77, what is it is giving. 5329 equivalent to 77. 5329 equivalent to 77 square. 9. 8 plus 2, 10. 7 plus 7, 14. 1 plus 4, 5. 5 square is 25. 1 equivalent to 7. It is not possible. If 1 is satisfying, another, definitely the numerical value is changing. The digital sum will be different. I hope it is clear, right? Square root of 7754. Any perfect square ending with 4. Tens place should be even. Yesterday class, I think you missed it. Tens place should be even. This is a non-perfect square. That is my next concept after I discuss this concept. I am still in this concept, right? I am still in the perfect square root of a perfect square. Glory at the end we will discuss. Next one. What are the other questions which I gave? 7744. Take a group. 4 is nothing but 2 square is 4 and 8 square is 64. So answer will have unit digit 2 or 8. 77 is 8 square 64, 9 square 81. Take the smallest value. So either the answer is 82 or 88. Just by looking at the question itself, 7700 is closer to 90 square. So answer is 88. Next one, square root of 1521. Keep a slash. 1 square is 1 or 9 square is 81. Keep the unit digit 1 or 9. 15 lies between which two squares? 3 square 9 and 4 square 16. These 3. Answer is 31 or 39. 39 is closer to 40. 40 square is 1600. 1500 is closer to 1600. These 39. These 39. Right? These 39. One more question I did not solve. Square root of 12544. 12544. First keep a slash after 2 digits. 4 means 2 square 4 and 8 square 64. These unit digit is either 2 or 8. Take the entire number. 125 lies between 11 square 121 and 12 square 144. So, take the smallest value. 112 or 128. 112 or 118. Sorry. 118 is closer to 120. 120 square is 14400. This 125. This cannot be the answer. This will be the answer. This will be the answer. Square root of 9409. 9409. Keep a slash after 2 digits. 3 square it is 9. 7 square it is 49. Answer will be either 3 or 7. 94. 9 square 81, 10 square 100. 93 and 97. 93. It is closer to 90. 90 square is 8100. This is a very big value. So answer will be 97. How to find the square root of a perfect square? Any doubts you got? How to find the square root of a perfect square? This is of the form 4 into 2 plus 1. These of the form 4 into 11. So, any number that whatever we have taken, right? Either last 2 digits will be 4k or 4k plus 1. Last 2 digits will be 4k or 4k plus 1. How to find out the square root of a non-perfect square? How to find the square root of a non-perfect square? How to find out the square root of a non-perfect square? Square root of a non-perfect square. 2 methods we will discuss. First it is root 13. Karthik, I will take after 2 problems. Method number 1. I told you already in previous, but I will discuss. Root 13 lies between which 2 numbers? Root 9 and root 16. Root 13 is greater than root 9. So it is 3 plus. 13 and 9, it is 4. 16 and 9, difference is 7. So these are nothing but 3 4 by 7. 3 4 by 7. 3 4 by 7. Method 1. Method 2. Both will give you a non-perfect square will always give you approximate values. A non-perfect square will always give you approximate value. This is Trachtenberg ways of This concept is developed by a famous mathematician, Trachtenberg. This is nothing but Ramanujam's method. Ramanujam's method. How he did it? The best thing is he did it at the age of 9th class, should be around 14 or 15. Root 13. Root 13 is nearer to root 9. 3. 3 plus 13 and 9. Difference is 4. Double this value. Both are approximate values. Both are approximate values. 3, 4 by 6. 3, 4 by 6. 3, 4 by 6. 3, 4 by 7 are very, very close to each other. 36 whole square is 1296. So 3.6 whole square is 12.96. Answer is 3.6, just something. Answer is, so this is giving you closest answer. Ramanujam's method will give you the closest answer. F of x is root x. Log f of x, it is nothing but half log x. This is nothing but 1 by 2 into 1 by x change x. This is this value. 1 by 2 into 1 by 3 into change is nothing but 4. This is the proof, Ramanujam's way of solving. And this is Trachtenberg's way of solving. You can take any method. It is ending with 3. Any perfect square ending with 3. It is not a perfect square. So, how to find out the square root of a non-perfect square? 2 more questions, but before that, let me discuss. Vamshi asked, what should we take digital sum? Vamshi, digital sum, digit sum. When you are adding the digits, digit sum has 2 definitions. Definition 1. Definition 1. It is nothing but sum of the digits. Sum of the digits. If the sum of the digits, it is 9. Definition 2. Definition 2. Definition 2, it is nothing but the remainder when you divide a number by 9. Remainder when you divide a number by 9. Practically, think logically. Digital sum. If you are adding the sum of the digits, if you are adding the digits, will you get 0? No. So, sum of the digits will be 9 only. But if the question is what is the remainder, 0 and 9 both are same from a digital sum perspective. I will not go 100 feet down. In some textbooks, there is another concept which is nothing but digit root. Digit root is nothing but remainder when you divide a number by 9. So, sum cannot be 0. If you are adding digits, how can the sum be 0? So, if you take this definition, sum of the digits is 9. If you take this definition, it is 0. 0 and 9 both can be used interchangeably. Both can be used interchangeably. Right? Next one. Aravind says, if it is a big number, can we take the 2 numbers and apply the logic? I will take a 6-digit number also. Please be little patient. Right? So, 9 and 0, both, right? Theoretically, both are same. I told you yesterday, ratio and fraction, theoretically, both are same. The definition wise, both are little difference. It is parts out of one quantity, multiple quantities selecting a quantity. Right, Vamshi? I hope I clarified it. Aravind, I will come back to you. Right? Asiya, for you. Root 13. Step number 1. Root 13 is nearer to root 9. 3 plus 13 and 9. What is the difference? 4. These double the value, Asiya. These nothing but closer to 3, 4 by 6. If it is root 37, these closer to root 36. 6 plus difference is nothing but 1. Double this value. These nothing but 6, 1 by 12. 6, 1 by 12. I hope it is clear. Suppose if it is, one student asked a doubt, Karthik, for you. root of 7754. Root of 7754. Just by looking at the question itself, what is the nearest perfect square? Either you can take 88 or 87. If I take 7754, these 88. These less than this value. 88 minus 10 divided by 176. Because, sorry, these 88 plus 10 by 176. This value is greater than this value. Sir, how you got directly? Yesterday I discussed how to find the square of a number using a square minus b square logic. That is exactly why your fundamentals should be extremely strong. I hope I answered your question. Right? I hope I answered your question, Karthik, I think. Right? Next one. Anyway, just by looking at a question, 7754, 54, last two digits is 54. 54 is 4 into 13 plus 2. It is 4k plus 2. That means I should apply the logic of square root of a non-perfect square. I should apply the logic of a square root of a non-perfect square. Just by looking at the question itself, I will come to know. 238. 238. A perfect square never ends with 2, 3, 7 or 8. So it is a non-perfect square. It is square root of 25. 15. 15 plus 13 divided by 30. Answer is 15 plus 13 divided by 30. 15 plus 13 divided by 30. I hope it is clear. Till 6th class I used to do this mistake. Don't do it. 6 2 1s are 2 3s are. This is a mistake. Don't do 15 2s are. That is a blunder, sir. Right? I hope it is clear. Next one. It is like saying, one student said it to me, sine inverse x and 1 by sine x. Both are different. Sine inverse x and 1 by sine x. Right? Now see here. That is inverse trigonometric function. Another is a reciprocal of a trigonometric function. Next one. I hope this idea, it is clear. Now, which logic to use? You know the concept of a perfect square. Aravind, for you. 1 plus 20 into 21 into 22 into 23. This is an original placement question. Options are 451, 461, 471 and 481. 451, 461, 471, 481. Generally what will happen is finding these values, adding 1. Then we have to do the square root method. In all these problems, these digital sum will work beautifully. Right? Digital sum will work beautifully. More than digital sum. Here tens place can give you the answer in 5 seconds. Tens place can give you the answer in 5 seconds. How it gives? So any number multiplied by 10, unit digit will be 0. Tens place is 1 into 2, 2 into 3, 6. It is 1. So the last two digits should be 61. Answer is 461. Answer dikh raha hai beta. Right? 5 seconds this question can be solved. 1 plus 20, 21, 22, 23. Any number multiplied by 10, unit digit is 0. Tens place is obtained because of this. Tens place should be 6. Even if you want to cross check, square root, I will remove it. 1 plus 20 into 21 into 22 into 23. It is 461 square. Let us check whether it is working or not. 1 plus 20 is 2. 21 is 3. 22 is 4. 23 is 5. 20, 60, 120, 121. 121 digital sum is 4. Answer digital sum is 4 plus 6, 10, 10 plus 1, 11. 11 digital sum is 2. 2 square is nothing but 4. 2 square is nothing but 4. 461 is the answer. Now, listen carefully, sir. I hope this idea, it is clear. How to find the square root? If there is a square root of a perfect square. By knowing all the logics of a perfect square, if I want to know the square root of a perfect square, use the concept of digital sum. Use the concept of digital sum. If I want to know the square root of a non-perfect square, don't use digital sum. Why we are not using digital sum? Because a non-perfect square always give you approximate value. Digital sum is always used for exact values. Non-perfect square will give you an recurring decimal. It will not give you an terminating decimal. Terminating means 0.15. Digital sum is 6. 0.232323. 2323. We don't know how many times it is repeating. 2 plus 3, 5. 2 plus 3, 5. If I take once, the digital sum is 5. Twice it is 10, 1. Thrice it is nothing but 6. So, digital sum, please write down. Digital sum will not work for recurring decimals. Digital sum cannot be used for recurring decimals. Digital sum cannot be used for recurring decimal. Here it can be used for terminating decimal. Digital sum can be used for terminating decimals. Can be used for terminating decimals. Terminating decimals. I hope this idea is crystal clear to you. Last one, right? In these digital sum, this is the best way to solve if answer options are given. I have seen a lot of students spoiling their time doing in a formula based approach. Application of digital sum in compound interest. Tomorrow and 3 to 5, don't miss the classes. 10 hours continuous arithmetic classes. I will give you no repeat telecast. You want to learn? Come exactly at the class, listen to the class. Sir, can you give me recording? No recording will be given. I cannot work with the whims and fancies of a student's availability for a non-enrolled students. Enrolled students, right? Because they paid for me, I have to respect the commercial they paid for me. So I give unlimited number of times viewing. It is similar to an Hotstar, sir. Hotstar 15 minutes, you can watch it live. Otherwise, you can subscribe for it. Otherwise, you can sign off. Right? Application of digital sum in compound interest. Now see, first question. This is an original placement question. Principal is 5,000. Tomorrow, 2 classes, I will explain multiple methods. PR is 18%. N is 2 years. Amount is how much? 6762, 6762, 6862, 6962, 7062, 7062. P is 5,000, R is 18%, N is 2 years amount. Look at Anil Nair's way of solving this question, right? I will tell you multiple methods. I want students to solve it. If there are some conditions, I will explain. Anyway, tomorrow's class, we are not going to use this formula. I'll start with the right basic, then I'll get into it. These everybody knows. These 5,000. One is 100%. R is 18%. Power 2. 5,000 into 118 divided by 100 power 2. Till here it is clear, right? Please don't show your mathematical intelligence, right? Just because you got great marks in school does not mean that you have an extreme understanding of this subject. Don't get into that myopic thought. 5,000, digital sum is 5. 118, 1 plus 1, 2, 2 plus 8, 10. 10 digital sum is 1. 1 square it is 1. 100 also it is 1. 5 ones are it is 5. Answer digital sum should be 5. 6, 9, 6, 2. 6 plus 9, 15. 15 plus 6, 21. 21 plus 2, 23. 2 plus 3, it is nothing but 5. 5000 digital sum is 5. 100 plus 18. 118 by 100 power 2. 5000 digital sum is 5. 118. 1 plus 1 plus 8. 2. Right, 1 square. 8 plus 1 can be cancelled. 5 ones are 5. Answer is 6962. What if more than one answer option has the same digital sum? That also I will explain, but let me solve some problems. Just by looking at the question itself, we are getting the answer. Next one, another exam question. P is 20,000. R is 40%. N is 3 years. N is 3 years. Amount equivalent to how much? 52. Right? 52. 8080. Right? 53. 8080. 54. 8080. 55. 8080. 55. 8080. But before that, let me take a doubt. Josna, did you do calculation right? I think you did a calculation mistake. Square root of 7744 is 88. 7744 is 88 square. 7 plus 7, 14. 14 plus 4, 18. 9 omitted. 4 equivalent to 8 plus 8, 16. 1 plus 6, 7. 7 square is 49. 4 plus 9, 13. 1 plus 3, 4. It is matching, right? It will match, right? It will match. Digital sum is the world famous concept, right? Probably most of you do not know when to apply, where to apply, how to apply, where not to apply. That is what actually in your college training programs, this is what needs to be taught. Other than coming with a sheet and asking you to solve 20 problems, that is exactly the reason most of the engineering students are regularly irregular to the training programs which happens in college, right? Because yada raja tada praja. Teachers are like that. 1 or 2 selected teachers will be good, right? Amount is nothing but principal is 20,000. 140 by 100 power 3. 20,000 it is 2. 145. 5 cube is 125. 8. 100 is 1. 2 8s are 16. 1 plus 6 is 7. Answer is 54880. Only once. Only once. See here, sir. 11 square is 121. Suppose if you want 101 square. Between two ones, I kept a 0. Between two digits, I kept a 0. Right side also. Between two digits, I kept a 0. Right? Next one. 100. 1 whole square. Between two digits, I kept 2 zeros. These are nothing but between two digits, keep 2 zeros. Very easy way of understanding this. Between two digits, if I keep 3 zeros, answer is nothing but 121. This is 000 and it is 20001. I hope it is clear. The same logic can also be used for cube. 11 cube is 1331. Suppose if I want 101 whole cube. Between two digits, I kept a 0. 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 Suppose if it is 1001 whole cube. 11 cube is 1331. Between two digits, there are 2 zeros. Between two digits, there are 2 zeros. Between two digits, there are 2 zeros. There is a beautiful pattern based on only ones, right? 11 square, 11 cube. Valid for 11 square and 11 cube. As the power increases, sometimes carry will come. So we will restrict ourselves to square and cube. 1 minute, sir. Just give me 1 minute. I hope it is clear. Next one. Please write down, sir. The class is full of shortcuts. Right? Now, everything will go it in a structured way. Next one. Square of the numbers containing only ones, and square we did it, and cube also we extended it. Second logic. Concept 2. Concept 2. I will discuss as per the concepts. Square of the numbers. Square of the numbers containing. Square of the numbers containing. A. Only threes. Only threes. Next one. Only six. Only threes. Next one. Only six. See, it is nothing but only nines. See here. Listen carefully. Only threes, only six, only nine. This logic is taken from the book Arthur Benjamin book of lightning calculations. Arthur Benjamin's book on mental calculations or lightning calculations. I'll give you the source from where this concept is being discussed right now. Suppose 3 square is 9. 33 square is there. 33 square. 9 in a 2-digit format. It is 09. If there are 2 3s, keep a slash before 9, keep 1 slash before 0. Suppose if it is 333 square. Now see here. 3 square is 9. 3 square is 9. How many 3's are added? Prefixed 2 more. So keep a slash here, keep a slash here. Suppose if it is 4 3 square is there. 3 square is 09. How many 3's are added? 3 here, 3 here. These 1 less than 9, these 1 more than 0. These 1 less than 9, these 1 more than 0. These 1 less than 9 and it is 1 more than 0. These nothing but a pattern recognition. Right? These 1 less than 9 and it is 1 more than 0. Suppose if it is 5 3's whole square. These nothing but 4 1's 0. 4 8's ending with 9. I hope the idea it is clear. Again I am repeating. 3 square is 09. 33 square. First write down 3 square which is 09. One more 3 is added. So keep a slash before 9. Keep a slash before 0. These 1 less than this number. These 1 more than this number. 3 square is 09. These 1 less than this number. These 1 more than this number. 3 square is 09. 3 more 3's are added. So 3 slashes here. This is the pattern which will be right for only 3, only 6 and only 9's. 6 square is 36. 66 square. First 6 square is 36. 1 more 6 added. 1 more slash, 1 more slash. These 1 less than this number, 5. These 1 more than this number, 4. 666 square. 6 square is 36. There are 2 6 added. 2 slashes, 2 slashes. 1 less than this number, 1 more than this number. 443, 556. Suppose if it is 4 6 square. 6 square is 36. 3 more 6 are added. Slash, 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 slash. These 1 less than this number and it is 1 more than this number. I hope the idea it is clear. Similarly, 9 square it is 81. 99 square. 1 more 9 is added. 81. So 1 slash here, 1 slash here. These 1 less than this number. 1 less than 1, 0. 1 more than 8, 9. These 999 square. 9 square is 81. 1 less than 2 more 9's are added. So 2 slashes. 1 less than 1 and 1 more than 8. Suppose if it is 4 9's are, it is there. 9 square is 81. 3 more 9's are added. 3 slash 1 less than 1 and 1 more than 8. Very beautiful analogy for only 3, only 6 and only 9. Same logic, same pattern, only thing. The values are different. Here it is 09, here it is 36, here it is 81. These 1 less than this number, 1 more than this number. 1 less than this number, 1 more than this number. 1 less than this number, 1 more than this number. I hope the idea it is clear. Right? I hope it is clear. Right? Now, 1, 2, 3, 4, 5, 6, 7, 8 into 6 9's into 6 9's. 1, 2, 3, 4, 5, 6, 7, 8 into 6 9's. So it is 6 9's, right? So 12 slash 3, 4, 5, 6, 7, 8. Left side of this slash, whatever number is there. add 1 to it and subtract it from the entire number. 1, 2, 3, 4, 5, 6. 78 minus 13, 65. 9 minus 3, 6. 9 minus 4, 5. 9 minus 5, 4. 9 minus 6, 3. 9 minus 7, 2. 10 minus 8 also it is 2. Try to do subtraction. You will find this method to be extremely easy. Extremely easy you will find. 972 into 99. You will get this kind of doubt. 972 into 99. 972. Keep a slash after 2 digits. 9, 1 added, 10. Subtract it from the entire number. 962. 10 is not subtracted from 72. 10 is subtracted from 972. 9 minus 7, 2. 10 minus 2, it is 8. 10 minus 2, it is 8. Now, 1 minute, sir. If it is given in the examination, probably you can do it in a different way. See here, 99. 99 is 9 into 11. 9 into 11. 9 into this number. Right answer digital sum will be 9. Answer digital sum will be 9. If any number is multiplied with 9. Please write down. If you multiply any number with 9, answer digital sum is always 9. Answer digital sum is always 9. If you multiply any number by 9. 9 into this one, right? So, answer digital sum will be 9. 9. 6 plus 2, 8. 8 plus 2, 10. 10 plus 8, 18. 1 plus 8, 9. This is multiple of 9. Answer digital sum should be 9. 5 plus 4, 9. 3 plus 4 plus 2, 9. Next one, 6 plus 6 plus 6, it is 9. Next one, 3 plus 2, 5. 5 plus 2, 7. 7 plus 5, 12. 12 plus 5, 17. 17 plus 1, 18. Answer digital sum should be 9. Answer digital sum should be 9. Answer digital sum should be 9. If you multiply any number by series of 9s, please write down. If you multiply any number by 9, answer digital sum is always 9. Let us check it out. 234 into 99. Okay, you might get this doubt. 178 into 4 9s. If the number of 9s are more than the number of digits, these is nothing but 0, 0, 178. Prefix zeros, it makes no difference. 4 9s are there. Keep a slash after 4 digits. 0 plus 1 is 1. 178 minus 1. 177. 9 minus 0, 9. 9 minus 1, 8. 9 minus 7, 2. 10 minus 8, it is 2. Answer is 1779822. 4 9s, it is nothing but 9 into 4 ones. Answer digital sum should be 9. 9 out. 7 plus 2, 9 out. 7 plus 2, 9 out. 8 plus 1, 9 out. Answer digital sum is always 9. Answer digital sum is always 9. If I multiply any number, any number with 9 as a digital sum, 9 are its multiples. Any multiple of 9, answer digital sum will be 9. Any multiple of 9, answer digital sum. Before solving this question, check with the answer whose digital sum is 9. Right? Sometimes probably 3 can be eliminated. If you are able to eliminate only 2, then use this approach. 2 plus 1 is 3. 234 minus 3. 231. 9 minus 3, 10 minus 4. 9 minus 3, 10 minus 4. Right? I hope the idea it is clear. 178 into 4 9s. Here the number of 9s are more. Vedasri. I added 2 zeros because I need to keep a slash. 4 9s, I kept a slash after 4 digits. It is a 3-step process. First keep a slash. Then work with left of slash. Then work with right of slash. 0 plus 1 is 1. It is subtracted. Right? To the left of slash, any number is there, add 1 to it. and subtract it. I told you that I will discuss the proof. 99 is 100 minus 1. 100 minus 1. 234. 00 minus 234. Am I right? Now see here. This is nothing but 100 minus 34. 66. It is getting carried. So it is getting carried. This is nothing but 233 minus 2. Or it is also nothing but 234 minus 3. From 4, 1 gone. That can be given to 2. That can be given to 2. I hope it is clear. It will become 233 minus 2. 233 minus 2. This is nothing but plus 1 and it is minus 1. So it is 234 minus 3. I hope the idea it is clear. Any number when you multiply with 9, answer digital sum should always be 9. Any number when you multiply by 9, right answer digital sum is 9. Now see here. Why are we keeping slash? This slash will tell us what are the numbers that I will write it down in a new slide. 234 into 99, it is there. I told you that it is 2 slash 34. These 231.66. Why the slash is kept after 2 digits? These number is nothing but the hundreds complement of 34. Suppose if it is 234 into 100 minus 1. These nothing but 234.00 minus 234. These nothing but the hundreds complement of 34. The slash will tell that anything to the right of slash. Anything to the right of slash. These nothing but the 10 power k complement. 6 slash 789. 999 is nearer to 1000. This will tell me, Sahana, that this is the 1000 complement of 789. This is nothing but the hundreds complement of 99. 1, 2, 3 into 5 nines. Into 5 nines. 0, 0, 0. These will tell me that this is the 10 power 5 complement of the right hand side. 10 power 5 complement of the right hand side. Shivakumar, tell me exactly where is the doubt in 341 into 333. I don't believe in rote based learning. You tell me where you are getting fumbled. Venkatesh says, all the problems which I did are with multiples of 9 only. Write 1768 into 999 for you, Venkatesh. These is nothing but 1 slash 768. 1 plus 1 is 2. Subtracting. These 1766. Every digit is 9 minus. Unit digit is 10 minus. 9 minus 7 is 2. 9 minus 6 is 3. 10 minus 8 is nothing but 2. These 232 is nothing but 1000 minus 768. 1000 minus 768. See, I am using this method to avoid subtraction. If I write like this again, you will get confused. So I used a line to the right hand side of slash. Every digit is 9 minus, unit digit is 10 minus. That is how you do the complements from 10 power k. That is how you do the complements. Kindly reply in the live chat in case you got any doubt. Why am I discussing this one? In placement, there is a question. Speed is 347 meter per second. Time period is, this was the question. Time period is 1000 seconds. 1000 seconds. Time period is decreased by 0.1 percentage. 0.1 percentage. Find the total distance. Find the total distance. If the time period is decreased by 0.1 percentage, find the total distance. Find the total distance. Speed equivalent to distance by time. Distance equivalent to speed into time. Speed is 347. Time period is 3. 1000. It is decreased by 0.1. 0.1 is 1 by 10. D is 1 by 100. That means it became 999. Now the time period is 999. Now you know how to solve. D is 0347. G is add 1. 347 minus 1, 346. 9 minus 3, 9 minus 4. 10 minus 7, 3. 10 minus 7, 3. Answer is 346653. 346653. I hope these where it is used. That is where it is used. I know why am I teaching a concept. I know where the concept can be used in the future. I know how to lift a student who is not good in aptitude. Some of you are very young, 20, 21. Maybe sometimes your ego will come first more than the logic, right? It is like Swami Vivekananda said to Ramakrishna Paramahamsa, right? You cannot be so knowledgeable sitting under a palm tree. He said that it is for you to decide whether I am knowledgeable or not. There is this movie where Milkha Singh, there is this movie where the Milkha Singh is running. The competitor says, right, this will become your last race. Right, this will become your last race. And the Milkha Singh says so beautifully, I will run like this race will be the last race. So one negative line from the competitor, he converted into a positive line. When the Dhanush made these album, why these Kolavaridi, right? Absolutely shitty lyrics. Absolutely there is no meaning in most of the lines. But it crossed some million views. And one critic has asked that, see, you made that music, everybody from the top of the music directors in other industry, they are probably telling that the song is meaningless. The way Dhanush responded to that question asked by a critic is, I am so happy that my song reached the toppest of the music director in India, and he took time to comment on. He took time to comment on my video. That means he has taken time to watch my video and comment on it. What better happy moment than this? One negative thing can be converted into a positive thing, right? So I always believe that when I'm taking a class, there are students who are at a non-mathematics background. There are students who are from Nellore. There are students who are from Bangalore. There are students who fear mathematics. There are students who are from good mathematics. I need to cater to everybody else, right? Definitely, if I am going on the road, if a dog is barking at me, will I bark at the dog back? If I bark at the dog back, there is no difference between me and the dog. I hope it is clear, right? Dakshita, the zero should be placed if the number of nines are more. 138 into, if it is 3 nines, 138 into 4 nines. This is nothing but keep a 0. So that you will keep a slash. This is nothing but T keep zeros. Here you can keep a slash. I hope it is clear. Dakshita for you. Let me check it out. Right, Shiva? 341 into 333. This is nothing but 341 into 3 into 111. I don't know where you are fumbled. Right, 4 3s are 12. 1023 into 111. 102300. Easily you are getting the answer right. There should not be any problem for this question. I hope it is clear, right? 3 into 230 plus x whole square. It is nothing but 492A04. A equivalent to. If you know the logic, you can find out this answer very, very fast. 3 into 230 plus x whole square is 492A04. This is nothing but 3 square is 9. So 9 into 230 plus x whole square. 9 into any number. If I multiply any number by 9, answer digital sum should be 9. Just now we discussed. Answer digital sum should be 9. 9 is eliminated. 4 plus 2, 6, 6 plus 4, 10. 10 plus a should be divisible by 9. After 9, what is the next multiple of 9? A is nothing but 8. A is nothing but 8. 10 plus 8 is 18. Time is 1000. It is decreased by 0.1 percentage. 0.1 is 1 by 10. Percentage is 1 by 100. So 1 on 1000. On 1000, 1 decrease Karimullah. So therefore the final answer will be 999. Therefore the final answer will be 999. I hope the logic is clear. Next one. I hope the logic is clear. Next, how to multiply any two numbers. Diagonal method. How to multiply numbers nearer to each other. How to multiply numbers by series of ones. How to multiply numbers by series of nines. Concept number 5. Concept number 5. Problems based on perfect squares. Concept number 5. Problems based on perfect squares. Listen carefully, sir. Problems based on a perfect squares. Suppose if I take x as a natural number. If I take x as a natural number. If I square these number, x into x, this will become a perfect square. If the power is 2 or the multiples of 2, 2 power 4, 16 can be written as 4 into 4. If the power can be written as a multiple of 2, then it is a perfect square. X is a natural number. So, x can be an even number or x can be an odd number. X is an even number or x is an odd number. Even number is 2k whole square. Odd number is 2k plus or minus whole square. Either it can be 2k plus 1 or 2k minus 1. This will become 4k square. This will become 4k square plus or minus 4k plus 1 plus or minus 4k plus 1. These perfectly divisible by 4. Perfectly divisible by 4. Perfectly divisible by 4. It gives a remainder how much? 1. Please write down this point. If the number is a perfect square. If the number is a perfect square. If the number is a perfect square, the form of the number is either 4 into x or 4 into x plus 1. Please remember, reverse may or may not be true. 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 If the number is a perfect square, if it is a perfect square, it will be of the form 4 into something or 4 into something plus 1. Suppose if the question is 5374, is it a perfect square? By using this logic, what are the last two digits of the number? 74. 4 into, why we are doing last two digits? It should be divisible by 4. 4 18s are 72. 72 plus 2. 4k plus 2. It cannot be. Answer is no. Suppose if it is 1329. 1329. Now see here. 1339 let us see. In the next problem I will do 1329. 1339. Last two digits is 39. 39 is 4 into 9 plus 3. It cannot be of the form 4k plus 2 or 4k plus 3. Very, very important logic. Please write down, sir. Please write down. If it is like I took a stone and I throw it onto the lake, waves will come. Waves will come. If I throw a stone, definitely ripples will happen. If I throw a stone, ripples will happen. Reverse case. For the water to form ripples, it is not mandatory that I throw a stone. Maybe somebody else would have thrown a stone. I hope it is clear. If I throw a stone, then definitely ripples will come. If the number is a perfect square, definitely it is of the form 4 into x or 4 into x plus 1. Next slide is extremely important. What are all the concepts related to perfect square? First concept, a perfect square never ends with Perfect square never ends with 2, 3, 7 or 8. A perfect square never ends with 2, 3, 7 or 8. Next logic. Tens place. Yesterday we discussed. Tens place is odd only when the units place is 6. In every other case, it will be even. Second logic. Any perfect square is of the form 4 into x or 4 into x plus 1. These are the various ways to check whether a number is a perfect square or not. Last logic. Now see here. Every perfect square has a digital sum. Every perfect square has a digital sum 1, 4, 7 or 9. Every perfect square has a digital sum 1, 4, 7 or 9. Reverse may or may not be true. If this is a perfect square, answer digital sum will be 1, 4, 7 or 9. If the number is a perfect square, the digital sum will be 1, 4, 7 or 9. Write down the proof. Write down the proof. Suppose if I take any digital sum is nothing but sum of the digits till you get a single digit number. These are all the possible digital sums. Yes or no? 91. What is the digital sum of 91? 9 plus 1, 10. 1 plus 0, it is 1. 181. What is the digital sum of 181? 1 plus 8, 9. 9 plus 1, 10, 1. What is the digital sum of 2, 3, 4, 1? Again 2 plus 3, 5. 5 plus 4, 9. Again it is 1. This is the set of all the numbers whose digital sum is 1. Set of all the numbers whose digital sum is 2. If I square it, 1 square 4. Next is, 1 square it is 1. 2 square 4. 3 square it is 9. 4 square 16 which is 7. 5 square 25 which is 7. 6 square 36 which is 9. 7 square 49. 4 plus 9 13. 1 plus 3 4. 8 square 64. 6 plus 4 10. It is nothing but 1. 9 square is 81. 8 plus 1 9. Right side, which all numbers we got? 1, 4, 7 or 9. 1, 4, 7 or 9. Extremely important point, sir. Very, very important point. Very, very important point. Every perfect square has a digital sum 1, 4, 7 or 9. Every perfect square has a digital sum 1, 4, 7 or 9. Reverse may or may not be true. Only if this is true, this will be true. Right? This is true. Right? I hope it is clear. Sahana, what is the doubt? A perfect square does not. You are saying what I said repeatedly. I said if the number is a perfect square, it should be 4 into x or 4 into x plus 1. You are doing the converse of this concept. You are checking this and telling me whether it is a perfect square or not. That is what that stone example I said it twice. If the number is a perfect square, it should be of the form 4 into x or 4 into x plus 1. If it is of the form 4 into x or 4 into x plus 1, it may or may not be perfect square. Don't take the converse. Don't take the converse. Here also don't take the converse. If it is a perfect square, the digital sum should be 1, 4, 7 or 9. Again, don't take the example of 22 and tell that it is not a perfect square. Converse may or may not be true. If I throw a stone, ripples will form in the lake. If I throw a stone, if this happens, that will happen. For that to happen, this may or may not happen. May or may not happen. May or may not happen. Right? I told you yesterday, Vamshi, any perfect square ending with 1, tens place should be even. 91 is not a perfect square. Please remember, if this is true, this will happen. if this is a perfect square, it is 4 into x or 4 into x plus 1. The digital sum will be 1, 4, 7 or 9. Reverse may or may not be true. Reverse may or may not be true. Reverse may or may not be true. I hope the idea it is clear. Now write down the questions. Is 1, 2, 3, 3, 2, 1. 1, 2, 3, 3, 2, 1. A perfect square. A perfect square. Is 1, 2, 3, 3, 2, 1. This is of the form 4k plus 1. So you might say that no, I said if this happens, this will be. I hope it is clear. Delete the digital sum. It is 3. If it is a perfect square, this should have digital sum 1, 4, 7 or 9. 1, 4, 7 or 9. If the number is a perfect square, it will be 4 into k or 4 into k plus 1. If the number is given, we have to check by using digital sum or some more concepts. 1, 2, 2, 3, 3, 3, 4, 4, 4, 4, 4, 4. A perfect square is 1, 2, 2, 3, 3, 3, 4, 4, 4, 4, 4. A perfect square. 1 plus 2 plus 2, 4. 3 plus 3 plus 3, 9. This is 16. It is 30. Digital sum is 3. If the digital sum is 3, it is definitely not a perfect square. It is definitely not a perfect square. Definitely not a perfect square. Any doubts you can ask. I created a question for one of the examinations some years before based on permutation and combination and this concept. Please write down. How many 5-digit numbers? How many 5-digit numbers that can be formed? How many 5-digit numbers that can be formed using the digits? How many 5-digit numbers that can be formed using the digits? 1, 2, 3, 4, 5. All are conceptual, sir. I'll keep creating questions. Absolute clarity of concepts, you will get it. As I keep repeatedly saying, neither these concepts nor these problems in a structured way, you will not find it in any textbook. You are writing notes, right? Right after the class, open Google and check it out. This is a structure derived out of 15 years experience. How many 5-digit numbers that can be formed using the digits? 1, 2, 3, 4, 5. Repetition not allowed. Repetition not allowed. Are perfect squares. Are perfect squares. Beautiful questions. Most of the students fumbled in this question. They thought the logic is very long. But actually, if you think logically, if you start looking at the way Anil Nair looks at this problem should not take more than 10 seconds to solve. How many 5-digit numbers that can be formed using the digits? 1, 2, 3, 4, 5. There are 5 digits and I need a 5-digit number. Repetition is not allowed. There is a 5-digit number. So, totally 5 numbers can come in 5 digits in 5 factorial. 120 numbers. How many numbers are perfect squares? 1 out of the 120 numbers. Can I write? It will be like this. Another number could be like this. Or another number could be like this. It could be anything. What is the sum of the digits? 5 plus 4, 9. 3 plus 2 plus 1. What is the digital sum? 6. Here also, what is the sum of the digits? 6. All the 120 numbers, digital sum is 6. For it to become a perfect square, it should have digital sum 1, 4, 7 or 9. It should have digital sum 1, 4, 7 or 9. So, therefore, answer is no 5-digit numbers. No 5-digit numbers exist. Beautiful question, sir. I hope you have understood this concept in clear. Everybody, kindly reply in the live chat if it is clear to you. If this concept is clear to you, Kindly reply. Everybody. Everybody, I hope this logic is clear. There is a 5-digit number 1, 2, 3, 4, 5. These 5 digits can come together in 5 factorial 120. So out of 120 numbers, all the numbers digital sum is 6. All the numbers digital sum is 6. So there is no number whose digital sum can be 1, 4, 7 or 9. Can be 1, 4, 7 or 9. I hope everybody it is clear. I hope this concept is clear for everybody.